right, people. So we're going to work on example 1, which is making a slope field. So I will tell you in advance that slope fields can be a little bit tedious if you're given as many points as I gave us here, which is 16 points. A typical slope field on the AP probably has, let's say, 6 to 9 points that you're asked to find. And if you have a slope field, it's probably part A of your AP free response, with part B or part C being the big point value where you have to actually solve the diffie-q. In this case, we can't solve the diffie-q because this is a non-separable differential equation. This is the same one that I gave you in the last video. So let's go ahead and get right down to finding our slope field. So the idea with the slope field is that the AP or whoever is going to give you a certain number of defined points. So here there are 16, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And at those 16 defined points, which is a lot, hence the frowny face, I'm going to find the slope by using the fact that dy dx is the same as slope. So on my table, I listed all the x coordinates and the y coordinates. So for instance, I always start in the bottom left. I don't know why. And I always just go like this. So I listed -2, comma, -1, -2, 0, -2, 1, -2, 2, and then so on in each column. Once you do that, your slope is going to be whatever your dy dx equation was, right? Whatever that diffie-q was. So my slope here is x plus y. So if we plug in the values, my slope at the first coordinate is going to be a slope of -2 plus -1, which is a -3, right? So let's draw that on here first. So that's saying at this point, I should have a slope that goes, remember it's rise over run, right? So down 3, right 1. So I don't actually have enough grid here to do that. So sometimes what you're going to have to do is count out down 3, right? Down 3, right 1, and then put your little snippet. That's my slope that's about a -3. So check, did that one. My next slope should be, and I'm just going to fill these out now, and then we'll sketch all of them in a sec. My next slope should be -2 plus 0, which is -2, -2 plus 1, which is -1, and -2 plus 2, which is 0. And I'm going to put a little star next to that 0 because that's going to matter in a second. -1 plus -1 is -2. -1 plus 0 is -1. -1 plus 1 is a 0. I'm going to put a star next to that because that's important. -1 plus 2 is a 1. 0 and -1 is a -1. 0, 0 would give me a 0. 0 plus 1 gives me a 2. 0 plus, or sorry, my bad. 0 plus 1 gives me a 1. 0 plus 2 gives me a 2. 1 plus -1 gives me a 0, which I'm going to star again because it's important. 1 plus 0 gives me a 1. 1 plus 1 is a 2. And 1 plus 2 is a 3. Okay, so the reason I starred all of those, and this is where we find out if my different color markers actually work. Hey, they're not dead. Right? All of those ones that are zeros are going to matter because when you look at an AP, they generally give you 1 point for all of the 0 or undefined slopes because those are ones that are easy to spot on an AP to see if you're right or wrong. So in this case, I know that at -2, 2, I should have a 0 slope, which is flat. I should have the same thing at -1, so that's -2, 2. At -1, 1, I should have the same thing at 0, 0, and I should have the same thing at 1, -1. So I'm going to make sure that all of those are right because on an AP, they're definitely giving me a point for that. Beyond that, all of the other ones, I need to have a close approximation to correct. So when I get over here, I have my -3 slope. This next one should be a slope of -2, which means down 2, right 1. So that's going to be like here, right? So notice that it is slightly less steep, but it is still negative. It's slightly less steep than my -3, but it's still negative. The next one should be a -1, so that's down 1, right 1, which is here, again, slightly less steep than my -2. I'm going to go ahead here and see that my slope at -1, 1 is a -2. Well, that's the same slope I had here, so I just copy my work, right? And then the next slope is a -1, which is convenient because that's the same slope I had here, so I just copy my work, right? So these are all done. At -1, 2, I should have a +1 slope, so that's up 1, right 1, so that's about there, right? There we go. At at 0, -1, I should have a slope of -1, which is this same -1 slope I have. So look how those are all the same. That's convenient. At the next one here, at 0, 1, I should have a slope of 1, which is up 1, right 1. Done. At 0, 2, I should have up 2, 1, 2, right 1. So that's a little steeper, but notice it's a positive slope. I already did my 0 slope there. I should have a slope of 1 here, right, which is up 1, right 1. So there we go. Then a slope of 2, which is up 1, 2, right 1, right? So kind of there-ish. And then finally a slope of 3, which should be my steepest positive slope. You can either count up 3, right 1, or you can kind of just say, hey, a little steeper than 2, and that's my slope field, right? Cool. So That's my slope field. Now, sometimes the AP will ask you to find a specific point. Sorry about that. The computer started to go to sleep. Sometimes the AP will ask you to find a specific point and then sketch a solutions curve. So, for example, if the AP had said, now we find out if my blue marker works, if they said sketch a solution through the point, let's pick, you know what? We'll go ahead and pick -2, 1. Right? So what they're saying is drop your leaf in the water at -2, 1, and then follow the arrow. Well, this arrow is going directly to the next arrow, which is going directly to the next arrow. So it turns out that in this case, my solutions curve actually just ends up being a line, right? So you're not always asked to do that, but if you are asked to do that, be mindful that that's something that could happen. Just to show you, if they ask me for a different one, I'm pretty sure I have a different color marker. If you were asked, oh, green doesn't work, I guess we're going to go with red. So if instead you were asked to sketch a solution through, let's do the point 0, 2. Well, here's 0, 2. And it's pretty steep in this direction, but what happens when I hit this entire wall of red is I get horizontal lines, and then it's going to bend up when it hits the curve that was the blue curve before. So what's going to happen is a curve that kind of looks like this. So what I want you to notice is that, again, like the river in the previous example, where the leaf is dropped has a significant result in the outcome. All right, that's it for example 1 on slope fields.